So 1-3 is all about modeling with your linear functions. And so we're going to use a lot of the same properties that you guys learned from Algebra 1 to sort of help us out here, beginning with our actual linear function, or y equals mx plus b. So this is the most important the most important equation that you're going to be using in this section. Of course, we have m, and I went ahead and put all of the slope information right here, m and rise over run, but most importantly, I need you guys to remember that your slope can be rewritten as y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And then, of course, your b value is going to be your y-intercept. Okay? So we can look at the pictures below, and we can follow our linear functions, or we can follow our Algebra 1 steps, and we have 2 points, so we can go ahead and use those 2 points to find our slope. So I have these 2 points. I'm going to label that 0, 50 as x1, y1, and I'll label the 10, 51 as x sub 2, y sub 2. I'll put it into my fraction, which should be 51 minus 50, all of that, over 10 minus 0. And the numerator will end up being 1, and the denominator will be 10. From here, we can just either look at our graph to find our y-intercept, which will be right here, the blue dot, or I can look at my equation right here, and I can see that it's underlined. I know it's going to be my y-intercept because x is 0, and then of course y has a value, which is in this case 50. So I can say that my b value is going to equal 50, and then I can plug it into my equation. I should say y equals 1/10 of x plus 50. Number 2 is the same idea. We're going to take our 2 points and plug them into our slope formula. So we can have 360 minus 0, all of that over 0 minus 6. And it doesn't really matter if you pick the top point as your first point or if you pick the bottom one as your first point. It doesn't really matter. You should always get the same answer, even if you flip it. So 360 minus 0, obviously that's 360. And then all of that is going to be over -6, which is going to equal -60. So our slope is -60, and unfortunately we cannot look at our y-axis and easily see where that y-intercept is, but thankfully we have a point, and so b is going to equal 360. Plugging it into our equation, we should have y equals -60x plus 360. So that's going to be the 2 examples we're going to do there. Number 3, I'm going to cross out only because it requires a different formula, which we will talk about in a second. So I wanted to include a quick SAT prep question. This question says, in 2014, County X had 783 miles of paved roads. Starting in 2015, the county has been building 8 miles of new paved roads each year. At this rate, if n is the number of years, write a function that represents the miles of roads paved. How much of the paved roads will County X have by 2030? So it has a lot of information, and then it has 2 questions for us. But the first thing we're going to do is answer that first question, which says, or first statement, which says, write a function that represents the miles of roads paved. This is a linear function. Our 783 right here, that is going to be our starting point, or our y-intercept, which is b. Then 8 below that is going to be our slope, or our m. We can take the b and the m and plug them into our slope-intercept form and get y equals 8x plus 783. And that is going to be our first answer, our equation. The next piece says, how much of paved roads will County X have by 2030? Well, the first thing we need to do is determine how many years transpired between 2014 and 2030. So you can do this pretty easily just by subtracting, taking 2030 minus 2014. That's going to be a total of 16 years. So I am going to take that 16 and I'm going to plug it in for my x value, which is technically supposed to be my n, but it's fine. So we'll say y equals 8 times 16 plus 783, and that should equal 911 miles. All right, and we'll say this is 911 miles after 16 years, or in the year 2030. So example 1.1 says find the equation of the graph, and it gives a paragraph just to sort of explain what the graphic is all about. And it says the graph shows the distant asteroid 2012 DA14, that's just the name of that asteroid, travels in x seconds. Write an equation of the line and interpret the slope. The asteroid came within 17,200 miles of Earth in February of 2013. About how long does it take the asteroid to travel that distance? So the first thing we're going to do is find our equation. So it says write the equation of the line, interpret the slope. I'm going to use my graph to help me find that. So I have 2 points. One is a little bit hidden because it's hitting at the origin, but that's 0, 0. And I can now plug this into my formula, and I'll say that it's going to be 24 minus 0 over 5 minus 0. And that's just going to equal 4.8. The other thing is that my y-intercept is at 0, 0. So I could either say b equals 0 or whatever I want to do there. But since it is 0, I don't really need to do anything with it when I plug it into my formula. So plugging it in would say y equals 4.8x. And this is the answer to the first piece. The next sentence says the asteroid came within 17,200 miles of Earth in February of 2013, and then it says about how long does it take the asteroid to travel this distance. Well, so the question is, what is x that gives us the y value 17,200? So I'm going to use my formula and plug in what I know. I know the 17,200 is my y, and I know it's my y because it's my distance. So I'll say 17,200 equals 4.8x. And then I'm going to do a one-step equation where I divide by 4.8 on both sides. And it's going to give me approximately x equaling 3,583. If I take a calculator, please understand that this is in seconds. So if I take a calculator and I divide that by 60, because 1 minute is 60 seconds, then it should give me, let me double check my work, but it should give me about an hour. And yes, it should equal 59.716 repeating minutes. So 59 could easily round to 60 minutes or 1 hour. So we could say that this is approximately 1 hour. And so we have answered that question. Example 1.2 says the graph shows the remaining balance y on a car loan after making x monthly payments. Write an equation of the line and interpret the slope and the y-intercept. What is the remaining balance after 36 payments? So again, our first step is to write an equation. We get that information from our graph. Here are our 2 points. We plug them into our slope formula, and we should have 18 minus 15 over 0 minus 10. So in the numerator, I should get a 3, and then in the denominator, I should get a negative 10. All right, so after that, I can look over on my y-axis and see that my b value is 18. Plug that into our equation, and we should get y equals negative 3 over 10x plus 18. All right, so if I were to interpret all of these pieces, I would say, okay, and remember 18, that y value, it represents thousands of dollars. And I know that because if you look at the graph and you look sideways on the y-axis, it says balance, thousands of dollars. So I initially bought this car for $18,000, which is it's decent. It's not great, but it's decent. And I am slowly paying it off, and 3 over 10 is the same thing as 30%, right? That's 0.3. So I could say that my b, or my y-intercept, is the starting value of the car being $18,000. And my slope, m, negative 3 over 10, is I'm paying 30% of it each month or by each payment. The next part of the sentence says, well, what is the remaining balance after 36 payments? So I'm going to look at my chart again, my graph. Number of payments is my x value. So I'm going to rewrite my equation, and I'm going to plug in a 36 for x. All right? I can take my calculator and figure out what it's going to be. It should end up saying negative 10.8 plus 18, which should give us 7.2. Now remember, 7.2 is the balance, and the balance is in thousands of dollars. So I could say $7,200, and since we're talking about the balance, that is what is left. So remember that question on the very front page on number 3 that we skipped? We weren't able to do it because it didn't have a y-intercept. And so the same thing is going to apply here. And so I'm going to show you that the method you're supposed to use for this. Again, this is something you learned back in Algebra 1, but we have something called the point-slope form. And so this is when you do not have the y-intercept, but you do have a point and you have the slope. So we have this table below. Let me highlight this. We have this table below, and I'm going to write it as ordered pairs just because I'm a visual person and I need to see it. That 1,7 can be rewritten like this, and that 3,11 can be rewritten like this. Now it's a little bit easier for me to plug it into my slope formula, so it should be 7 minus 11 over 1 minus 3. The numerator will be a negative 2, the negative 4, and the denominator will be negative 2. This, of course, is going to equal a positive 2. So now I'm going to go to my point-slope formula, and so y is going to be just part of the formula. And I'm going to use this point off to the right, and I'm going to use this one because it has the smallest numbers, 1 and 7, as opposed to 3 and 11. So I'm going to use that and plug it into the y position. The 7 is in the y position, so that's going to go next. And then I'll carry the other pieces, equals, my slope is 2, parenthesis x, and then the x sub 1 is going to be that 1 from the ordered pair. So I'll say minus 1. All right, and then from here I can do the distributive property. I can rewrite y minus 7 equals 2x minus 2. Add 7 to both sides, and you should get y equals 2x plus 5. So that's just a quick review of what you're supposed to do with the point-slope formula. So here's some examples for you. Again, we're following the same process again. I am going to rewrite my x, y in the chart as an ordered pair just to make my life a little bit easier, and then I'm going to plug it into the formula. I'm going to have negative 2 minus a negative 1. Those are my two y values, over my two x values, 1 minus 2. All right, I have two negatives, so that'll be a positive there. And negative 2 plus 1 in the numerator is now going to be negative 1. And then in the denominator, it's going to be 1 minus 2, which is negative 1. Of course, anything over itself is going to equal just positive 1. So now that I have that, I can use the point-slope form. Y, and I'm going to use this ordered pair off to the right, again, because it has the least amount of, really it's just the smallest one that I see right now. I could use 3, 0. 3, 0 would give me the same answer. If you do not like negative signs, you can always use any of the points in here, any that look the easiest to you. So I'm going to use this top one just to make it a little more challenging. So y minus, and the y value here is a negative 2. So I'll say negative 2. And this is going to equal 1 times x minus, and the x value of that ordered pair is a 1, so let's say minus 1. Use the distributive property, it's just going to give me the same thing. On the left-hand side, those two negatives make a positive, and so it should say y plus 2 equals x minus 1. Subtract the 2 on both sides, and you should get y equals x minus 3. All right, so if we look on the right-hand side, we see a XY chart, and it's just oriented differently, but it's the same thing. Again, I'm going to write my order pairs to make my life a little bit easier. It's going to be 330 and 880. After I do that, I'll plug it into my slope formula. So I'll do 30 minus 80 over 3 minus 8. So in the numerator, I should have a negative 50, and then in the denominator, negative 5. Divide this out, and you should get a positive 10. So I'm going to use my point slope form. I'll say y, use the 3 and 30 because it's the smallest one I see. So it'd say y minus 30 equals 10 times x minus 3. Do the distributive property, and the left-hand side stays the same, but the right-hand side ends up being 10x minus 30. Add 30 on both sides to isolate that y, and you should get y equals 10x, because those 30s end up canceling out. All right, so let's compare two equations at the same time now. Example 3.1 on the left-hand side says 2 prom venues charge a rental fee plus a fee per student. The table shows the total cost for different numbers of students at the Lakeside Inn, while the total cost y in dollars for X students in Sunview Resort is represented by the equation y equals 10x plus 600. Which venue charges less per student? So the first thing we need to do is we need to have two equations, because if we have one equation and then one table, it's hard to compare information. So if we have information presented the same way, it just makes our life a little bit easier. So the first thing I'm going to do is I'm going to write down something that I already know. I already know that Lakeside Inn is related to the table, and the Sunview Resort is represented by this equation. So I'm going to write that really fast. I'll use SR to make my life a little bit easier and say that it is y equals 10x plus 600. And then I'm going to go over to the Lakeside Inn, and I'm going to use my point slope formula to create an equation for this table. So first things first, I need my slope, and so I'll use 1500 minus 1800 over 100 minus 125. And this is going to give me a negative 300 over negative 25. If I reduce down, that'll give me a 12. So I'll say my point slope form, and I'll use that first ordered pair, 100, comma, 1500. I'll say y minus 1500, because that's my y value, equals 12, because that's my slope, times x minus 10, or 100, excuse me. I'll use the distributive property. So the left stays the same, and I have 12x minus 1200 on the right, and then I'm going to add 1500 on both sides. Again, the purpose of that is to isolate the y. So this gives me y equals 12x plus 300. All right, so I have answered the first question. I have found the information to answer the first question. Now that I have two equations, all I need to do is look at our m value, our slope of each equation, to figure out what is the cost per student. So which venue charges per student? The Sunset Review charges $10, and the Lakeside Inn charges $12. So I can say the Sunset Resort charges less money. I'll just say less for now. And that is my answer. Okay, so then the second question says, how many students must attend for the total cost to be the same? Well, if two things are the same, that means they're equal, right? So I'm going to take my two equations that I have now, and I'm going to set them equal. So it's going to say 10x plus 600 equals 12x plus 300. Again, I'm setting them equal because the question is, when will they equal? When will the cost of these tickets be the same, or the cost of the venue? Now that I have this, I want to isolate my x, because that's my only variable. So I'm going to move this 10x over to the side, and this cancels out on the left. I'm left with 600 equals 2x plus 300. And now I'm going to subtract 300 to the other side, and I should get 300 equals 2x. If I divide each side by 2, I should end up with x equals 150, and remember, x represents the number of students. So how many students must attend for the total cost to be the same for both venues? We would have to have at least 150 students. All right, same idea for 3.2. The question says the cost of parking in a parking garage in Chicago is represented by the equation y equals 15x plus 20. Where y is the total cost in dollars and x is the time in hours. The table shows the table shows the total cost to park in a parking lot in Denver, Colorado. Which city's parking garage charges more per hour and by how much? All right, so first things first, we're doing the same idea as before. We have Chicago information, which is represented by the equation, and we have Denver information, which is represented by our table. So I'm going to copy down what I already know, which is about Chicago. So I'm going to copy this equation down. And then for our Denver information, I'm going to figure out what the slope is really fast. 43 minus 51 over 2 minus 3. I'll get negative 8 over negative 1, which equals positive 8. So Denver is going to be represented by y minus 43. Remember, we're using our point slope form, not our slope intercept form, equals 8 times x minus 2. Okay? Distributive property comes next. And then I'm going to add 43 on both sides because I want to isolate my y. And I should get 8x plus 27. All right, so again, the question is, which city's parking garage charges more per hour and by how much more? Chicago is $15 per hour and Denver is $8 per hour. So I could say that Chicago charges $7 more, and that is my answer. The next sentence or question says, after how many hours would parking in both cities cost the same? So again, I'm going to take my two equations and set them equal to each other. 15x plus 20 equals 8x plus 27. You're going to subtract 8x on both sides. And I'm moving the 8 because it's the smallest number. Just like on the left-hand side with the prom venues, I moved the 10 on the left-hand side to the right-hand side because it was the smaller out of the two. So it doesn't really matter which way you go. You always want to move the smaller amount. So I'm moving that 8x on both sides. I should get 7x plus 20 equals 27. Subtract the 20, and we should get 7x equals 7. Divide by the only number we have left, which is 7, and 7 divided by 7 is 1. So this, again, is representing that we have 1 hour before the parking costs between the two cities are equal or are the same. So let's end with a quick SAT practice question. This particular question says, Sherry uses a ride service to get back and forth to work. In her town, there are 2 services from which to choose. Give Me a Ride charges $10 plus $1.25 per mile, but rideshare charges just $2.50 per mile flat. Let M represent the number of miles traveled, and then which of the following statements are true? Choose all that apply. So with this one, the first thing we are going to do is just, again, we're going to create equations for our 2 particular things that we're comparing, which are the ride-sharing services. So there's, I'll represent Give Me a Ride with a G, and I'll connect that with the $10. And that $10 right there is going to be our starting cost no matter what. So that's our B value. And then the $1.25 is per mile. So because it's per mile, that's going to be our M. So if I were to create the equation, it would say G is going to equal 1.25 M, because that's per mile, plus 10. And then the next one is the rideshare, and that is just $2.50 per mile. So we'll say R equals $2.50 per mile. So now that we have our equations, we can go ahead and check out our information, that they give us, so that we can select all that apply. The first one says 2.50 M represents the total charge for the rideshare. So if we look over here, 250 M, and then over here, they match, and so we would say, yes, this is true. The next one says 125 plus 10 M represents the total charge for Give Me a Ride. Well, if I look over here on the right, I actually see that the M, the variable, has moved around, and so this one is not true. All right, number 3 says, Sherry lives 5 miles from work. It will be cheaper for her to use Give Me a Ride. Well, let's see. Let's take that Give Me a Ride formula and plug in 5 miles. So 1.25 times 5 plus 10. That's going to give me $16.25. Well, let's compare that to rideshare. That'll be $250 times 5, which is going to equal $12.50. So in reality, this is actually not true. The rideshare will be cheaper, so we can say that that is not true. The next one says Thomas travels 20 miles. It is cheaper for him to ride with Give Me a Ride. All right, let's plug that in for both of these, see what we get. Give Me a Ride is $35, and rideshare is going to end up being $50. So that is a true statement. Give Me a Ride is going to be cheaper in this case. All right, the last one says the price for 8 miles is the same for both companies. So again, let's plug in those 8 miles. 125 times 8 plus 10 equals 20. And then for the rideshare, 250 times 8 equals 20. So that is a true statement.